Hello and welcome to lesson 1.1. Today we're going to look at variables and expressions. More specifically, we're going to look at modeling relationships with variables and equations. Before we get started, we need to understand what a variable is. A variable could be something like x, t, z, r, okay, any type of a letter. Now, an expression is a mathematical phrase that can include numbers, variables, and operation symbols. So I could have something like 2 plus 1 is an expression, 3r, 5x minus y, and so on. There's many different examples. So what we're going to do in example 1 is we are going to write out with numbers and variables and or operations our word sentences. So if we look at this first one, it says 7 more than n. More than indicates that we are adding. So I would have 7 plus n. If we go across from that one, we see that it says the product of 7 and n. Product indicates that we are multiplying, so you can write this as 7 times n, or we could just do 7n. Next, we have the difference of n and 7. So with subtraction, order does matter. When I add, like up above, 7 plus n or n plus 7, it will give me the same answer. But when we're subtracting, we do have to pay attention to the order. Okay, so for this one, it says the difference of n and 7, so this will be n minus 7. The quotient of n and 7, again, when we're dealing with quotients, this is division, and the order of division does matter. So here I have n divided by 7, or you could write this as n divided by, I can't get that little dot. There we go. 7. Either way, I'm okay with. Next, it says the quotient, which means division, of 4.2 and c. So we could do 4.2 divided by c. And finally, we have t minus 15. So this indicates subtraction, and we can just write it like that. Example 2 is going to be very similar. It says write an algebraic expression for each phrase. So here I have 4 more than p. So this tells me that I have 4 plus p, because more than indicates that we're adding. Number 3 says 12 minus m. Number 5, quotient indicates division. So this is going to be n divided by 8. And for number 7, it says 23 less than x. Less than indicates that we are subtracting. And because it's worded as less than, that means that we're going to be subtracting the 23. So here we really have x minus 23, which is the same thing as 23 less than x. Example 3 is similar still again. It says define a variable and write an expression for each phrase. So now though we're not gonna be given the variable, we can just write whatever variable we want to. So for number 9, it says 2 more, so this indicates addition, than twice a number. Well, twice a number is multiplication. So this is going to become 2 plus, we'll say 2x. So I have 2 more, so 2 more than twice some number. For the next one, we have 9 minus a number. So 9 minus, we'll say a number n. 13 says the product of 5 and a number. Well, product indicates multiplication. So I could say 5t. And 15 says the quotient of a number in 6. So here I might just take my variable to be q, and I'm going to divide that by 6. And again, you can pick whatever variables you choose. For example 4, number 25 says the sum of 9 and k minus 17. So here we have the sum, which is addition, and then minus is a subtraction. So this would be the sum of 9 minus, the sum of 9 and, which indicates plus, k minus 17. For number 27, it says 9.85 less than the product of 37 and t. So this is a multiplication, and because I'm going less than that amount, that means I have to subtract the 9.85 from the product of 37t. So I have 37t minus 9.85. Next, we have 15 plus the quotient of 60 and w. So I have 15 plus, remember quotient is division, so this would be 60 divided by w. Number 31 says the product of 5 and m, and then comma, minus the quotient of t and 7. So the product of 5 and m is just 5m. Then from that, we're going to subtract the quotient of t and 7, and quotient is division. So that would be t divided by 7. 32 says the sum of the quotient p and 14 and the quotient of q and 3. So the quotient of p and 14, so this is p divided by 14, but I'm going to add that because it says it's the sum, and we're going to be adding that to another quotient, which is q divided by 3. And our final part to example 4 says 8 minus the product of 9 and r. Now for example 5, we're going to actually switch things around a bit. So for 34, we are going to write a phrase when we're given the expression. So you can go the basic route and say q plus 5, but I would encourage you to try to expand your vocabulary a little bit and say the sum of q and 5. So that's 34. Now for number 35, and I'll write that down here below, it says 3 minus t. So you could do 3 minus t, or I could say the difference, and there will be multiple answers for these. The difference of 3 and t. Number 36 says 9n plus 1. So I could write this as the product of 9 and n, and then we could say plus 1. Okay, or again, there's different ways that you could write this. 37 looks like we are dividing there, so you could say the quotient of y and 5. And for 38, it looks like we're multiplying 3 things together. So for 38, we could say the product of 7, h, and b, if you would like. The next thing we're going to look at are equations. Now, equation is a mathematical sentence that uses an equal sign. Okay, so it's essentially an expression that has an equal sign. Once you add the equal sign, it becomes an equation. An open sentence, just in case you ever see this term, is an equation that contains one or more variables. So you could have something kind of like what we've been doing, 3x plus 5 equals 2 or something like that. Now, one thing I did want to point out though, okay, is that when you're writing a word equation, if you see the word is, okay, is typically suggests that there's going to be an equal sign. So if I say the product of 3 and 5 is 15, okay, that is means that we're going to put an equal sign there. So let's take a quick look and see how this works. For example 6, it says Track One Media sells all CDs for $12 each. Which equation, which we'll come up with, best represents the cost C of a given number of given number N of CDs? So in this case, we know that our cost is going to equal the cost of each individual CD, 12, multiplied by the number of CDs that are sold or purchased in this case. So C equals 12 times N. So when we come down below for part A, it says, suppose the manager at Track One Media raises the price of each CD to $15. Now we have to write an equation to find the cost of N CDs. So again, our cost is equal to the individual cost of each CD multiplied by the number of CDs that are purchased. And for part B, it says, suppose the manager at Track One Media uses the equation C equals 10.99N. What does this mean? So pause the video, think about it, and then come back. So if we know that N is our number of CDs, this means that the 10.99 must be the cost of each CD. Okay, and clearly it looks like it's a discounted cost. So now for example 7, we're going to come up with a variable and write an equation to model each situation. So for 17, it says the total cost, so usually I like to use C for cost, is, notice I have that word is, which means equal, the number of cans times 70 cents. So I'm going to go 0.7 times my number of cans, and I'm going to call the number of cans N, since I don't know what that is. Number 18 says the perimeter of a square equals, so perimeter is equal to 4 times the length, which I'll use L, of each side. 19, the total length of a rope in feet used to put up tents is 60 times. So length is equal to, because I have the word is, 60 times the number of tents, which I'm going to use T to represent the number of tents. And finally, for number 20, it says, what is the number of slices of pizza? So I'm going to put P. I don't usually like to use S because sometimes S's look like 5s. So I'm going to put, what is the number of slices of pizza left from an 8-slice pizza after you have eaten some slices? So I'm starting out with 8 slices, but we're going to eat some of them, which means we're taking them away or subtracting them. I don't know how many we're subtracting, so I'm going to use the variable N. So now we're given a table, and I want to see if I can come up with a relationship to find my cost when I'm starting with a $20 bill. And I get that information because I can see that my cost is right here, and then I see that I'm starting out with a $20 bill because it says a change from 20. So the cost of my purchase, again, I told you I like to use the variable C for cost. So I'm going to say C is equal to the cost. And I need to know, we'll say, so this is cost of purchase. And I need to know what my change is from a $20 bill. So for change, I'm just going to use the variable, we'll say G. So G is going to equal the change from a $20 bill. So when I go to write this equation, I know that I'm trying to find out the amount of change that I get. So that means change is equal to, I'm starting out with a $20 bill, and then I'm going to be taking away the cost of my purchase. So 20 minus C. So here I can see that the amount of change I get back is equal to my $20 bill minus the cost of my purchase. Now for example 9, I would like you to pause the video and try to do this on your own before you see the answer. In this case, I see that I have the number of workers and I have the number of radios that are built. So I'm trying to figure out how many radios are built based upon the number of workers I have working. So I'm going to define my variables. So I'm going to say that W is equal to my workers. And I'm just going to use R is going to equal the number of radios built. So number of radios built. And when I come up with my equation, because I'm looking for the number of radios built, I'm going to say that R is equal to, I see that when I have one worker, I get 13 radios. So if each worker can build 13 radios, that means I have 13 radios times the number of workers, or 13 radios times W. So the equation for this table here is R equals 13W. Please let me know if you have any questions. Otherwise, I hope you guys have a great day and we'll see you in class.